Hi everyone, my name is Harsh Kumthekar and I'm a student of Gisma University of Applied Science. And today I will be going through my project, which is based on e-commerce database systems. And I will be talking about the designing and the implementation of it. My student ID number is GH1047816. So the domain I've chosen for this project is an e-commerce platform, and the goal is to design and implement a fully functional relational database and that can efficiently manage the customers, the products, the orders, as well as suppliers and payments. So going through this, I will be looking at the key goals, which is applying normalization, defining integrity constraints, implementing the CRUD operators, which is create, read, update, delete, and I'll also be providing clear documentation and a working GitHub repository. So the chosen domain is the e-commerce platform. So we have these six main entities, and which is customers, products, orders, and order details, transactions, and suppliers as well. So the customers basically is for storing user details, suppliers are for who provide the products, and products is basically with price and stock, and orders are placed by the customers. Order details, which acts like a junction table to handle the many-to-many relationships between the orders as well as the products. So the relationships are clear. One customer can have multiple orders, and one order can have many products via the details table, and each product is supplied by one supplier. So now going into the system design. So I have an ER diagram here which shows the relationship between the attributes and the relationships. So we can see here the order details, products, suppliers, transactions, orders, and customers. So all of them are linked to each other. This is the ER diagram. And we've spoken about the relationship. So the relationship here is just about one to many, and one to many, many to one, many to one, and one to one. We've gone through that, and now looking into the problems. So the problems which I had was about the insertion, update, and deletion anomalies. So what I did here was to ensure the data integrity. I just applied normalization up to the third normal form. I eliminated the repeating groups to achieve the first normal form, and I removed the partial dependencies to get the second normal form, and removed the transitive dependencies to get the third normal form. And for example, the supplier information is already stored separately from the products to avoid like duplication. So that was that. And the column, these are like some of the column names of my tables, the foreign keys as well. And going ahead, these are the queries which I have done in my project on my SQL workbench. And these are the outputs which I retrieved from them. And I also utilized some advanced queries. So I looked into the advanced queries of inner join, aggregation, and group by, left join, as well as stored procedure. So let me go to my workbench. So as you can see, this is my SQL code, and looking into this, I have applied certain commands. Let's start with the inner join. So I use the inner join because first of all, I want to see all the orders with the customer name. So I run an inner join between the customer as well as the orders. And as you can see, the result is basically one of the customers ordered a laptop and another customer ordered a phone. It's attached on my Word document as well. So the next query is talking about the aggregation and the group by. So I utilize the group by commands as well. So the group by, the reason why I use group by is basically if I want to know how much each customer spent in total, I run a query joining the customers, the order, as well as the order details, and then group them all together by the group by command, and using the customer ID, and the result is just going to show the total spent by the customer per customer. And then I also utilize the left join, which is stated here. I utilize it here. And the left join is just used because if I want to find customers who haven't placed an order yet, I just use the left join and check for null order IDs. I utilize a stored procedure as well as a trigger. So I created a stored procedure which is named as get customer orders that takes the customer ID as an input. And for the trigger, I set up a trigger that just automatically calculates and updates the total amount every single time. So it keeps on updating it every time a new item is added to the table, the order details table. And this is done with my code. let me head back to my Word document. So going into this, bro, based on my challenges and my solution, I had a few challenges which I faced in the early stages once I got the project, and I worked on it and I utilized some of these solutions which helped me overcome my challenges. And looking into the conclusion and the summary, so just to summarize, the project successfully delivers a relational database for an e-commerce platform, and it meets all the key requirements: the proper normalization, the complex joins, the aggregations, the stored procedures, as well as the triggers. So for my future work, I would definitely like to work on adding more indexes for my foreign keys to improve the query performance, implement a view for monthly sales reports, and connect this backend database to a front-end application using Python or PHP. So thank you so much for watching, and the full code and my documentation are available in the GitHub repository link. And have a great summer to everyone. Thank you.